Welcome to the ultimate radio test. We are testing each of the common and very popular aircraft radios on this table. So without further ado, let's dive in to this test. So starting left to right, we've got an FrSky radio. This radio was provided to me by my friend Randy Smith. I did reach out to FrSky. They never really got back to me with a commitment on sending me a radio or receiver, so I just ended up getting this from my friend Randy. Thank you, Randy, for the FrSky radio. PowerBox, reached out to PowerBox USA, and they absolutely jumped on the chance to send me this radio. So this is a PowerBox USA loaner radio that they sent. They also sent a receiver. We'll cover that. And thank you, PowerBox, for wanting to participate in this test. It speaks volumes. The Jeti DS24 radio is mine. It's currently what I fly pretty much all of my aircraft with. So I did not reach out to Jeti to see if they wanted to participate because we had the options available. Spectrum IX20 radio is also mine, and the Spectrum radio, I did not reach out to Spectrum, but we had this radio because it is a shop radio that we use to set up customers' planes and also to fly foamies. The JR D-Force 28X radio, that's another one from a friend. So with JR D-Force, I did reach out to them and they showed some interest, but it never went anywhere. So we have a friend's radio here, the older 28X, and that is what we're going to be using for this test. Futaba, I did reach out to Futaba USA and they declined to participate in the test. So we ended up finding a Futaba radio that locally here, one of my friends organized it, so I'm not sure whose radio this is, but thank you for that. Thank you for allowing us to use the Futaba radio. And RadioMaster, we actually have two options here. So I reached out to RadioMaster and they sold me a Boxer radio and a couple of receivers for a steep discount to participate in the test. And we also had one of our local friends here, Bill, who gave me his radio, the TX16S, to use in the test. Thank you to RadioMaster for organizing this, and also to Bill for supplying the radio that he owns. The goal here is to demonstrate each radio with each receiver setup that's available. Now, there may be other options available, but what we're using in the video is what we were able to access and organize in time for the video. So let's review each radio and receiver setup that we're going to be using in the test. So with the FrSky, we are going to be using the TD R18 receiver setup. Now this receiver setup is a 2.4 antenna and also a 900 antenna. The antenna on this radio is currently on the 900 is set to 25 MW, which I'm assuming is milliwatts. The second receiver we'll be using is the S8R receiver, and this operates on a 2.4 band only. For the PowerBox setup, now PowerBox supplied the radio and the receiver for the test, and we are using a PBR 9D receiver for this test. So for Jeti, we will be using a few different configurations. Configuration number 1 is going to be an R3 receiver. Now I generally don't use these in any of my models, but we will try just a standalone R3 receiver. We'll be using all of this through a central box just to keep things nice and easy. The second setup we're going to do is a Rec7 standalone receiver. These came out of one of my models. And these receivers have the 40 centimeter dipole antennas. The next thing we'll do is a Rec7 primary with a Rec7 clone. Again, both of these receivers have the 40 centimeter dipole antennas. And the last setup we're going to try is a Rec7 primary, Rec7 clone, and a 900 megahertz backup added to the system. So with all of these options with Jeti, this will give a very good representation of the different options available. For Spectrum, we will be using a couple different variations here. So we're going to be using an AR630, which is one of their newer receivers. That will be our first one we try. The second one we'll be trying out is the AR636A. Now this has a couple different antennas on it, which is why I wanted to try this one out as well. And the last one was supplied by my friend Aaron. Aaron, thank you for this. So this is an AR9020, and we'll be trying this one out with 3 Spectrum satellites in the mix. JR, we are doing the 28X test. We'll do it with a couple different scenarios here. So we're going to use one of the older receivers. So this is a RG613BX. So we're going to use that receiver as a standalone. This has dipole antennas. We are going to add a RA01T into the mix just to see if that makes a difference. And then we will also test out a newer RG812BX receiver. With Futaba, we will be using an R617FS receiver. So for the first RadioMaster radio, we have, I believe this is the ELRS, or long range antenna installed. And we are going to be using it with a Beta FPV ELRS receiver right here. Now this may not be a fair comparison because from what I've heard, the long-range antennas and such, you do lose a lot of resolution. But it's nice to just have this option in the mix, so it's part of the comparison. Our other radio is the Boxer radio from RadioMaster. Now, this is going to be the normal RadioMaster comparison. Now, the ELRS system, I think, is available for all of their radios, but with the RadioMaster Boxer, we are going to be using the E6 receiver to run our test with this Boxer radio. So one thing to be aware of on the RadioMaster setup here, now I'm not going to play with the other radio, I'm just going to play with this one here. So we've got options for output power. Now according to the manual, the ELRS module is capable of providing 25 milliwatts to 1000 milliwatts of RF output. We are in non-extreme circumstances, 100 milliwatts of output at 500 hertz is recommended. So we've set the number to 100 and we've set the hertz to 500. Now be aware that in FrSky radio there, it's been set up by Randy to 25 milliwatts. So what we're going to do is we're going to test this radio at 100 as suggested, and then we are also going to do a test at 25 just to see the comparison. So let's review the criteria of the test and the way we'll be testing these radios out. Now, the purpose of this test is not for a specific radio, but more about protocols and options available with various receivers within each radio system. So throughout the test, I'll be speaking in kilometers because obviously we're located in Canada. Now, 50% of my viewers are located in the US. So as I speak about kilometers and distances and everything, I'll make sure I put a list down below what kilometers equates to in miles. The multiplier is 0.6. So 1 kilometer is 0.6 miles. 100 kilometers an hour is 60 miles an hour, to give you an idea. So close to the shop, there's a section of road that is 26.6 kilometers long. That section of road, from what we'll refer to as home base is where the radios are going to be parked. So from home base, we've got about a 7-kilometer stretch going up a nice, gentle hill to the top of a large hill. Once we hit that 7-kilometer mark, the hill starts to descend. Now, I don't have any clue how far these radios are going to make it, but as soon as we start descending over top of that hill, if we actually get to that point, things are going to become a very big challenge for any of these radio systems. Now, we will have the radios at home base and somebody will be manning the radio as soon as we leave home base. And what we are going to be doing is a slow rotation of 2 channels on the radio. So the point of that is going to be 1, 2, 3, 4, 1, 2, 3, 4. That is how our stick is going to be moved. Now we'll have a board set up on the tailgate of a truck. I'll show you guys that once we actually make it. And there's going to be 2 little extensions on each servo, like little flags, and those are going to move independently of each other as the stick gets rotated. The third criteria for the test is going to be a failure of radio signal. So from that position number 2, we will continue on until we lose radio signal or it becomes super glitchy, I guess we'll call it that. So either complete loss of signal or to the point where it's cutting in and out over a few seconds where it's just not even usable anymore. That's going to be failure point number 3. Now each of the receiver setups will be powered with a 2-cell LiPo, and that's going to either be plugged directly into the receiver or it's going to be run through, in the example of Jeti, through the central box system. The only exception to that rule is going to be the Futaba radio. I'm going to have to look up what power that receiver should be used at. We may be powering it with a 2-cell Life battery. If it can accept 2-cell LiPo, then we will power that radio with a 2-cell LiPo. So here's a record of information sheet that we've already filled out. As we've gone through these radios, we've listed each layout that we're going to be testing, and our line of sight pass is either a yes or no in this check mark. We've got a distance to interference and a distance to signal loss, which we'll be recording. All right, so we've got everything laid out for the test. The test will commence tomorrow. We're just charging all of our radios. We've got our test stand here built. This is going to go in the back of the truck. 2 servos, flags attached to the servo so we can visibly see them. All the different orientations for antennas and mounting and everything. This is going to be fun. All right, guys, we are out here at our test site. So our road starts right there and travels that direction, which is east. That hill that you can see, it keeps going further in the distance for 7 kilometers, 6.7 or something like that. We'll just say 7 kilometers that direction. Our home base is right here. So we've got a table set up. Each radio is going to be in the same spot on the table facing the direction of travel. Now we've got our board set up in the back of the truck, and the board has all the different configurations possible for the various radio systems. So what's going to happen during this test is we are going to go to that location right there. We are going to reset the distance or the odometer on the vehicle and start driving east. There's going to be 1 radio operator and they are going to stir the stick. So it's going to be a 4-second count. 1, 2, 3, 4, and continue the entire test. We'll be in communication via cell phone the entire time, but that is what's going to happen with the radio. As the sticks are getting stirred, those 2 flags on the board will operate, which is simply set up as an aileron and elevator channel. So we are going to be recording the radios, I think, for the radios that actually show signal here. So as example, FrSky, we're showing our signal there. Ward, if you can stir those sticks so we can see what happens. So that is what's going to happen as the sticks get stirred on the radio. All right, so this is the very first test, the FrSky. We are going to our stopping point first, and that will be step number 1. This is our line of sight test. So here's our line of sight test. We're pulling over in this same spot every single time, and the actual distance here is 0.7 kilometers. I'll convert that to miles and that will be on the screen. Now if you look way far in the distance there, I'll zoom in. That is our home base right there. So this would be line of sight about as far as we get away while flying a normal plane. So we'll continue on and see when we first get our interference. Now we're connected to home base by cell phone. Home base, if you can hear us, what's the signal strength on our radio?
You're still, yeah, you're at 47, 5 bars.
5 bars, 47. Oh, we're starting to get a little jittery. Just keep going, yeah.
You're at 49.
45, 5 bars.
We're getting on the pesticide level. Looking at 43.
Okay, so things are getting fairly jittery here. 1.8 kilometers. You can see the servos there moving. They're kind of going hop, 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 hop.
Signal went up. And you're climbing, I think.
Okay, as we're climbing, the signal's going up. Things are still moving good.
You're back down to 46, 47.
Okay, 46, 47.
45.
And what's our distance right now?
2.7.
2.7 kilometers.
You're back up here, going back up to 48.
Now we're going past line of sight.
So we're going on a little bit of a decline now. Oh, there we go. Fail. What's our distance?
Yeah, it was 3.
So distance is 3 kilometers
Just we hit the top of that hill.
with complete signal loss. Okay guys, so one of the problems we had going this direction here was there's a little bit of a dip in the road, which is where we started to get a bit of a jittery signal, and then we started going up the hill, and as soon as we went over top of the hill, we lost signal. So we're, from square one here, we're gonna change things around a little bit, and we're gonna head this direction, which is south. Now this direction may be hard to see it on camera, but there's a nice steady incline all the way up that hill. If I had to make a guess, we're probably about 4 kilometers up that hill, which is going to be like 3.2 miles, I think is what it works out to be, 2.8 or something like that. So we're going to do the exact same test with the same receiver, that direction, and that may be the direction that we travel throughout the rest of the test. So we'll repeat, go that way. Okay, we're on our way to our different direction and our line of sight location. So we're going to pick a spot similar distance down the road. That's safe to pull over every single time. Sticks are being stirred, and we are repeating the test. So line of sight, radio's still working fine. We'll just keep traveling down the road. So we've got a bit of a dip in the road here, but we still have line of sight to home base. So we're at 1 kilometers, which is 0.6 miles.
45.
Signal's at 45.
What distance are you doing line of sight?
We've already done line of sight. Line of sight is good. We won't stop for line of sight. We'll just confirm that it still works. Oh, there we go. We have loss of signal.
1.5
1.5.
kilometers.
So let's keep going. We'll keep traveling up the hill to see if it reconnects.
Telemetry recovered.
Oh, there we go. We have telemetry again. So that was complete loss, or that was interference at 1.6 kilometers. Signal's around 40.
2 kilometers.
We're at the 2 kilometer mark. And we still have line of sight to home base. That's the difference with this direction, is we can see home base the entire time.
Still floating around 40.
We're at 2.5 kilometers. The The radio at home base is giving us a warning signal. Coming up to 3 kilometers, which is where we lost our signal last time.
Back up to 48, 49, 50.
So we're starting to come up the large hill at the end of the road, which gives us more elevation. We're at 3.5 kilometers.
You're in the mid-40s. 50 now. You're 50 now.
So we're gaining more elevation here. We're at the 4 kilometer mark. And we're getting glitches.
You're at 55.
4.4 kilometers.
We're at 4.4 kilometers. Signals at 45 to 50. We still have line of sight to home base. Wow.
Coming up on 5 kilometers.
Everything's still working. Signal strength is hovering about 50. Getting little glitches in the... Oh, and
5.4.
complete signal loss at 5.4 kilometers. So we've lost signal completely. Okay, so our next receiver is going to be an interesting change. So this is a R18. Now this receiver here, as mentioned previously, we've got a 900 antenna and a 2.4 with a dipole antenna. So this is going to be interesting to see how it performs on that same road. We got a dip at about 1.4 kilometers, 1.5 kilometers where it lost signal. So I don't know if that's going to be a generic thing across all of the radios or if this is going to deal with that better. So let's continue on and we will see how this second FrSky receiver performs. Okay, odometer has been reset and we are starting to stir the sticks. What's that?
We lost your 2.4.
So the 2.4 has been lost.
I think your 900 is lost to 53.
So we still have signal. Servos are still working. What's our distance?
1 kilometer.
So we're at 1 kilometer right now. Let me know when we're at our line of sight location.
1.6.
Okay, so this is our line of sight location. We still have good signal. A little bit of a glitch right there, which is the same as the last receiver. But we still have signal.
Signal's holding at 20 and 53.
5 kilometers.
All right, we've hit the 2.5 kilometer mark.
Signal's holding at 20 and 53.
Signal's holding at 20 and 53.
That's correct.
We hit the 3.5 kilometer mark. And we've hit the 4.5 kilometer mark. This is a little bit of a dip in the road. Still have good signal as far as servo response is concerned. Five-kilometer mark. Servos are still responding properly. Bit of a dip in the road now. I believe this is where the other receiver failed. 5.5 kilometers. Getting a little bit of jitter now, so this would be interference point at 5.5. 5.7, complete loss of signal. Okay, so next up is our PowerBox core setup. Everything's working like it should. All right, and there we go. We've got our signals and everything. Okay, step one with PowerBox is line of sight. So when we get to 1.6 kilometers, we will confirm that line of sight still works. What's our distance?
Oh, you lost one. The other one's at 90.
It's at 1 kilometer.
Okay, so 1 kilometer, this is where we had a dead zone with our FrSky stuff, and PowerBox is dealing with the dead zone, no problem at all. Still have perfect movement on the servos. Oh, we've got interference and loss of signal.
1.5 kilometers.
So 1.5 kilometers, complete loss of signal.
And screen blacked out and not flashing for 0 and 4%.
So we've got nothing. We'll keep going down the road a little bit to see if it picks it back up. But I still have line of sight to home base, and we have no signal.
Transmitted here.
2 kilometers.
We're at the 2 kilometer mark. And dead. Still nothing. On our way back to home base, it finally clicked back in, and we're really not that far away. You can see home base right there. We were probably half a kilometer away, and it reconnected. All right, guys, that PowerBox result was a little surprising, so we're gonna repeat that test just to be fair, because it should have made it further than that. So we've powered off the receiver, we've powered back on the receiver, and we're gonna try that test again and see if anything changes. All right, so we're resetting the odometer, and test number 2. What's our signal on the radio saying?
It's not 100 and 100. Dropping down to mid-90s.
So mid-90s now on signal on the radio.
0.4 kilometers.
We're at 0.4 kilometers.
Mid-90s still.
Mid-90s on the signal.
Number 1 dropped down. It's dropping a lot now.
Okay, antenna number 1 is dropping.
0.7.
We're at 0.7 kilometers.
70 and you're at 0 and 40.
0 and 40 on antennas.
0.9.
0.9. Complete failure right now. 1 kilometer. Oh, we've got signal again. We're going to keep going. So the PowerBox core didn't deal with the little dead zone very well. What's our distance?
1.2.
So our distance is 1.2 kilometers. And loss of signal. 1.3 kilometers, loss of signal. All right, so we're continuing down the road just to see if it reconnects, but
2 kilometers.
the other radio system so far had no issues. We're at the 2 kilometer mark. I can see the receiver from here, and there's a flashing red light on the receiver. Home base is still moving the stick and nothing. So we'll go to the 3 kilometer mark and see. Oh, there we go. We've got intermittent signal again, but stopped
2.6.
at 2.6 kilometers. Home base, try and hold the radio up and down vertical.
3 kilometers. There. A little bit. 3.
So we've got intermittent jittery signals. So the radio's vertical right now, home base. Okay, so with radio vertical, we still have signal now, and the green light's back on and it's connecting. Loss of signal completely. 3.5 kilometers, loss of signal with radio position changed. All right, guys, well, we tried with the PowerBox system. We gave it 2 goes just to see. That second one was a little bit better. Now, throughout that test, I asked Ward to put the radio vertical. So I believe you probably went like this.
I went like this.
Okay, so you changed the position of the radio a little bit.
Yeah, and then it's still a 0, and then I have to go this way, and then then eventually I had to go this way.
Yeah.
And that's when you got the further signals, and then it lost.
Okay, so obviously antenna direction does make a big difference, but the one common with all of these tests that we're doing is the radio is sitting on the table. They are all in the same orientation. So unfortunately, that's the results from PowerBox. All right, so we're moving on to Jeti. We are starting off with an R3 receiver, which is fairly common. Many people use them. Checkpoint number 1 will be the 1.6 kilometer mark, which is our line of sight mark. How's our signal doing, home base?
7.
Signal's at 7 and 7.
0.4, 0.5, half kilometer.
So we're at 0.5 kilometers.
This is that crazy right here.
What's it? What's that?
33%, 37.
1 kilometer.
You're at 5 and 6. You're at 36%.
Okay, so no problems through the gray zone. We're at 1 kilometer mark.
Coming back up. You're at 5 and 7.
5 and 7 are our signals.
You just dropped down to 8% per second there. 5 and 6 at 30%.
How's our distance?
1.4.
Okay, so 1.4 kilometers. Oh, we have signal loss. We've gained signal again a little bit. Still signal loss. So we still have movement now. What's our distance?
1.7.
1.7 kilometers. And we are very interfered on the signal, very jittery. So telemetry signal is gone.
2 kilometers.
We're at the 2 kilometer mark.
Coming back now.
We're at the 2.5 kilometer mark.
Let's come back up. 5, 5, and 25. 5, 5, 23. 5, 5, turns 38. 5, 5, 19. Now down to 8%.
3 kilometers.
3 kilometer mark.
3, 5, and 22%, 11%.
We're at the 4 kilometer mark.
We're back up to 77 and 100%.
So signal strength is 77 and 100%.
Now drop down the rock again. Yeah, get back up and get going all the way up and down. 6, 100%.
4, 4.
We are at 4.4 kilometers.
5, 7, down to 34. 4, 6, down to 10. 4, 6, back up to 30. 55. 60%. 7, 8, 100%.
5 kilometers.
We're at the 5 kilometer mark. Still good movement from the servos.
About 7, 99%. 5, 6, down to 27. 5, 5, 20.
Okay, we're getting some interference, some jitteries.
5, 3.
We're at 5.3 kilometers. Loss of signal, 5.3 kilometers.
5.4.
Round number 2, we are using a Jeti Rec7, which is a standalone receiver, and it's got the 2 dipole antennas, 40 centimeter long. Okay, odometer's been reset, and we are making our way. So we're at 0.5 kilometers, still good signal.
7, 7.
This is where we generally get a little bit of interference because of the dip in the road. No change to signal. Radio is still responding perfectly. And we're at the 1 kilometer mark.
400%. 3, 3, 25. 3, 5, 4, 5, 95. 3, 4, 3, 3, 100%. Now down to 45%.
What's our distance?
1.4.
3, 3, 24%.
Okay, we've got a little bit of interference here, loss of signal.
0.6. 1 mile.
1.6, we're going to keep going. This is where we've had issues with pretty much every radio so far.
Still not picking it up.
And we still have no signal.
2 kilometers.
We're at the 2 kilometer mark. And we have signal starting to return.
2.2.
2.2 kilometers.
3, 3, 8%. 3, 3, 1%. 3, 3, 15%.
3 kilometer mark. And we are at the 4 kilometer mark.
6, 6 at 100.
4.5 kilometers.
We are at the 4.5 kilometer mark. 5 kilometer mark.
5
loss of signal?
5.3 kilometers.
5.3 kilometers loss of signal. So here's a view coming back to home base. When we hit about the 1 kilometer mark to about 1.6, that's where we're getting a bit of a dip in the road. Now that's way up the road there. So we've got 3 green bins. That's kind of where the dips have been starting, or the dropout initially has been starting. So this position right here is kind of the low spot in the road where we don't really have line of sight to the home base location. And you can see down the road there's a little bit of a bump in the road. As soon as we crest that little bump, that's when we can see home base again. Okay, so setup on Jeti number 2 is we have a primary receiver and we've got the clone plugged in. Now the clone, we've got our antennas organized in a separate position here, and that is our next setup. So with the clone's not going to send back any telemetry data, so we may lose telemetry here, but it may still work. So that's going to be one of the interesting parts of this. Okay, so starting over with the clone and primary. So it's this position right here in the road where we start to lose visual sight with home base. You can see the grain silos there on the left.
1 kilometer.
1 kilometer.
You're at 33 and 85.
Still perfect movement from the servos. Okay, a couple jitters there, which is pretty typical. What's our distance?
1.6.
1.6, which is normal. So we will keep going. And we've got servo movement starting again.
What's that?
2 kilometers.
Are you still circling the sticks home base? And servo movement has started again. Distance?
2.2.
2.2 kilometers.
$2.5.
2.5 kilometers. .5 kilometers. Five kilometers.
6, 7, 100%.
This is when we start.
Signal is 6, 7, and 100%.
Five,
5.2 kilometers.
3, 4, 50%.
5.3 kilometers.
Lost telemetry.
5.4 kilometers. And loss of signal. Distance?
5.5.
5.5 kilometers. Okay, so this setup here, we've got our primary receiver, our clone, and we also have our 900. I've confirmed that everything works as a standalone, so the 900 works by itself, the clone works by itself if the other two are disabled, and this would be probably our most rock solid Jeti setup that you can get. Okay, so full Jeti setup through Central Box, beginning.
$1 kilometer.
1 kilometer, just passing the 3 green bins. This is normally our dead zone. we still have signal. Distance?
80%.
Distance?
1.4.
1.4. Couple jitters like normal.
Lost telemetry.
1.6.
1.6 kilometers.
Lost again.
And we are picking back up full movement.
2 kilometers.
2 kilometers.
Stall.
Two 2.4 kilometers.
We're at 5.
5 kilometers. We have a couple jitters and loss of signal, 5.4 kilometers. Okay, next setup is the standard spectrum receiver, so the AR630. No satellites, no antennas, no nothing. All right, spectrum test has begun.
I have 0 bars.
0.5 kilometers. And we've got some interference. What's our distance? 0.8 kilometers distance for interference. We've also got no movement, so I would consider that signal fail, but we're going to keep going.
1 kilometer.
We're at the 1 kilometer mark.
Should get better.
Getting a little bit of jitters back.
1.2.
1.2 kilometers.
Still
1.5, still nothing. No movement on the servos.
Steering the sticks, right?
Yeah, we usually repeat about 2.2.
So we'll keep going to 2.2 to see if we regain signal.
2 kilometers.
2 kilometers.
Slow it down. Because that's how the antenna works. From the top to the protector. Let's go back to
2.2.
2.2 and still nothing. All right, we're gonna call that an end. We're gonna return to home base. All right, so now we're going on to the second spectrum receiver. This one has antennas built into the receiver. 0.6 kilometers.
Alright, so pages. We lost telemetry.
And loss of signal. Getting a little bit of interference at 0.8 kilometers. No movement on the servos.
1 kilometer.
1 kilometer. Still no movement on the servos.
1.5.
1.5 kilometers, still no movement on the servos. 2 kilometers, still no movement on the servos. Chase car in tow. Apparently he does not know that he can pass us. Still no movement on servos.
2.5.
2.5 kilometers. All right, so our last Spectrum setup, we have a 90-20 with 3 satellites. Now we've got 1 satellite this way, 1 satellite that way, 1 satellite straight up and down. All right, Spectrum receiver number 3 underway. 0.5 kilometers. All right, we got jitters on the servos, 0.8. Interference, servos have stopped moving. They're moving intermittently now.
1 kilometer.
1 kilometer loss of signal. No servo movement. Got intermittent servo movement again.
1.2.
1.2 kilometers. Loss of signal.
1.4.
1.4 kilometers.
$2.5.
2.5 kilometers, still no servo movement. Test over, returning to base. All right, so next setup here is the JR613BX, and we've got the small satellite receiver, and we are ready to go.
0.5.
All right, 0.5 kilometers, no change in signal, servo movement. All right, we're getting a couple jitters on the servos.
0.8.
0.8. Servos are jittering. We've got intermittent servo movement.
1 kilometer.
1 kilometer. All right, still intermittent servo movement.
1.2.
1.2 kilometers. Servos have stopped moving.
1.5.
1.5 kilometers. Waiting for radio to regain signal. Still no movement on the servos.
2 kilometers.
2 kilometers.
2.4.
2.4 kilometers. Still no movement on the servos.
2.5.
2.5. Test is over. And returning to home base. All right, so we've got our second JR receiver here. This is an 812BX, just the 2 dipole antennas.
0.5.
0.5 kilometers, servos still operating perfectly. All right, servos are getting slightly jittery.
0.7.
0.7. Loss of signal at 0.8. Intermittent signal.
1 kilometer.
1 kilometer, no signal. We've got intermittent servo movement.
1.2.
1.2. Still no servo movement.
1.5.
1.5 kilometers. 2 kilometers, still no signal, no servo movement. We are coming up on 2.5 kilometers, still no servo movement, no signal. Test is over. All right guys, so we've got the Futaba set up now. This is the 617FS on a 2-cell life battery. All right, odometer's at 0 and test has begun. .5 kilometers, everything working as it should. .8. All right, we are getting servo jitters at 0.8, but still operating.
1 kilometer.
1 kilometer, servos still moving as normal. We've got some servo jitters, but still operating.
1.2.
1.2 kilometers. Failure of servo movement at 1.4 kilometers. Stick is still being moved and no response from the servos.
2 kilometers.
2 kilometers. Still no response at 2.5 kilometers. We will end the Futaba test. Okay, so next radio we're doing here is the RadioMaster TS16S. Now, this is currently set up to 250 milliwatts.
On Express LRS.
On Express LRS. So this is the strongest signal we're going to test in the ELRS system. The other RadioMaster that we're going to try, the Boxer radio, we're going to have it set at 100 and then down to 25, which is more comparable to what you would generally use. And then here is our RadioMaster setup with the Super P 14 channel RX ELRS. We are at 0.6 kilometers, everything operating as normal. 0.8 kilometers, normal operation. 1 kilometer, everything operating as normal.
.5.
1.5 kilometers, everything operating as normal. 2 kilometers, normal operation. So looking at the servos, we're losing a little bit of resolution. Everything's operating as normal, but I can tell that the servos have
4 kilometers.
Poor resolution compared to normal. We're at 4 kilometers. Servos still moving fully. Same thing, drop in resolution is noticeable, but servos still operating.
4.9.
4.9 kilometers. Wow.
Yeah. .3 kilometers, normal operation. Home base is now out of sight, behind the hill. 5.6.
5.6 kilometers, servos still operating as normal. Lower resolution, but still operational. Servo starting to jitter. We're coming down the other side of the hill.
6 kilometers. 6 kilometers. Servo's very intermittent operation. We're going to continue straight on this road. We've hit the furthest that we've ever driven yet. Servo's still operational.
How much you lost here?
And we have lost complete signal.
6.2.
6.2 kilometers. Oh, signal's back. Let's keep going. Home base is completely out of sight on the other side of the hill.
6.5.
6.5 kilometers. Signal is intermittent, in and out, in and out. Servos are intermittent, in and out, in and out.
How much you lost again?
So we'll call that complete loss of signal. What's our distance?
6.6.
6.6 kilometers. Servos have stopped moving. All right, so we've got our other RadioMaster setup here. Basically, it's the same telemetry or same protocol, same everything as our last radio, but this is a different receiver. So just to confirm here, our TX power is at 100. The previous one to this was at 250. So we're going to do our 100 first, and then we'll try the 25 and see how that performs. Odometer reset. Test has begun at 100 milliwatts. So it's going to be interesting to see how the lower power setting makes it through the dead zone. So this is at 0.5 kilometers right now. 0.8 kilometers, everything operating as normal.
0.5.
1.5 kilometers, everything operating as normal.
Oh, there we go. Signal this morning. Where are you at?
1.7.
1.7 kilometers, servos still operating. Coming up on 2.5 kilometers, everything operating as normal. Five kilometers, normal operation. We are starting to crest the top of the big hill. 5.3 kilometers. We are losing sight of home base. Servos now responding slightly jittery, but still responding.
5.5.
5.5 kilometers, still responding. We have interference now, 5.5 kilometers. And loss of radio signal, 5.7 kilometers, loss of radio signal. All right, so test number 2. So we've dropped the radio power to 25 milliwatts, and we are beginning to go. 0.5 kilometers, normal operation. 0.8 kilometers, normal operation. 1 kilometer, normal operation. 1.5 kilometers, normal operation. Oh, we got a little bit of a servo jitter there, but everything operating as normal. Oh, intermittent signals. So servo interference, 1.5 kilometers. Loss of radio signal at 1.8 kilometers. We'll keep going to 2.5. We've got very intermittent signal right now. 2 kilometers. Back to normal operation. Back to intermittent operation. 2.5 kilometers, everything operating like normal.
kilometers.
4 kilometers, normal operation. Intermittent servo movements. Back to normal operation.
4.5.
4.5 kilometers.
5 kilometers.
5 kilometers, operation normal. Still getting warnings from the radio saying RF signal low. And we are starting to crest the hill and losing sight of home base behind the hill. 5.3 kilometers. And servo's becoming jittery.
5.5.
Servo's very jittery at 5.5 kilometers. Still moving. And loss of signal.
5.7.
5.7 kilometers loss of signal. So let's discuss and summarize our findings of the radio test. Now I've gone ahead and we've done two things. Number one, I've edited the video, which is about an hour long, and I've reviewed and made notes on all of the different tests that we did. Then I went and graphed our test results on two different graphs, which I will be popping up on the screen here as we review our findings with these radios. Now, a couple of points to think about. Was this a fair test? Well, it's a fair test with regards to the fact that every single one of these radios was under the same circumstance. We even made a bit of an exception by being so surprised at the results of the PowerBox test, lifting the radio up during the second test run and seeing how that affects everything. Was it an ideal condition test? Not really, because when you're flying a radio, any of these radios, and you're using an aircraft, your aircraft is higher. In our case, we had a fairly steady incline on the road, but at about 1 kilometer, there was a bit of a dip in the road, and then it started picking back up. Now that added some interesting dimensions to all of these radios. So before I get into the charts and the information and each of these radios, let me just preface and say this test was not designed or meant to bolster up or knock down any radio manufacturer. This was simply to gather information for myself, for other modelers, for you guys, and it's just an interesting look at how each of these radios deals with the different circumstances. So the first chart we'll put up here is with just the yellow on it. Now this shows the 3 radios and receiver combinations that did not have any interference in our 1 to 1.5 kilometer zone that had a bit of a dip in the road. They're the only radios and receiver combinations that performed flawlessly to the very end of the test. The second chart we put up here has yellow and red. Now the red is the radio systems that lost signal and did not recover. Now Spectrum, all the combinations, lost signal, didn't recover. We went further up the hill and it never recovered signal. The JR D-Force 28X combination with the receivers also did not recover its signal. The Futaba did not recover its signal, and the PowerBox also did not recover its signal. It did recover when Ward held the radio up in the air above his head. So we're going to also include that in the red zone as well. So let's review all of these radios in the order that we tested them in. I'll preface this and say any of these radios will probably fly your plane just beautifully. They're all great radios. They're all great manufacturers. Choose a radio that you're happy with and you're comfortable with and use it. You won't be disappointed with any of these radios. They all have the possibility of having issues, glitches, failures. It's an electronic mechanical device. That is definitely possible. So starting off with FrSky. Now the first receiver is just the 2.4 receiver. It did have interference at the 1.5 kilometer mark. It recovered by about 2 kilometers and it went to 5.4 kilometers. Performed as we would have expected, I guess, once we saw the comparison to all of its competitors. Once we added the 900 receiver in, so the 2.4 and the 900, it had 0 glitches in the dead zone, we'll call it. We'll just refer to that as the dead zone. And it managed to go 5.7 kilometers before it had a loss of signal. Now, the 900 signal is adjustable. And again, this was set to 25 milliwatts in the radio, which is a normal number according to what I've heard. Okay, next we're going to look at the PowerBox core. Now the results from the core were so surprising that we actually ended up doing the test twice, as you saw in the video. And what happened was we lost signal at 1.3 kilometers and the signal did not recover. So we continued down the road, didn't recover, and then our home base held the radio up like this, and then eventually above their heads, and we got intermittent signal back, but we did end up losing signal at 3.5 kilometers, which was very shocking. So that was unfortunately the result of the PowerBox core, and that's why it gets the red line on the graph. Next radio is Jeti. Now for me, one of the most kind of amazing things was the R3 receivers. Now the R3 receivers are the standard antennas and that setup performed very well. We did lose signal at 1.5 kilometers. We regained signal at 1.7 kilometers. So there was a very small portion of the dead zone, kind of the tail end of the dead zone where it lost its signal, regained it. The radio ended up and receiver combination ended up going 5.3 kilometers. Now that result was pretty much the same throughout all of the tests. So when we added a Rec7 instead of the R3 and then a clone and then a 900, the numbers didn't really change. We kind of lost signal at 1.6 kilometers. We regained it later on with the Rec7 at 2 to 2.2 kilometers, and the final distance went 5.3 to 5.4 kilometers. So all the numbers were very similar. Didn't really matter what receiver option we used. So moving on to Spectrum, the IX20 and the 3 different receiver setups, those are also all in red on the second chart. Essentially what happened is we lost signal, or we got our first interference at 0.8 kilometers with every receiver setup. That didn't matter. And we did kind of get it back with the IX20 and the 3 satellite combination. So it sort of had signal till about 1 to 1.4 kilometers, and then it lost signal completely, did not regain signal as we went further. So that result was pretty consistent with any of the Spectrum setups. All right, so the 28X with the various D-Force receivers, very similar result. We lost signal, or we got interference at 0.8 kilometers. It did not recover. It was sort of intermittent. The first receiver, we lost complete signal at 1.5 kilometers. The second receiver, 1 to 1.2 kilometers. So very similar results with the 28X setup. All right, Futaba, again, they're red in the column as well too. So Futaba, we got some interference at 1.2 kilometers is when we noticed our first interference, and we lost signal at 1.4 kilometers, and it did not regain signal as we started going out of the dead zone and up the hill, and that's the reason the Futaba is in red as well. So the RadioMaster TX16S with the ELRS system set to 250 milliwatts was hands down the clear winner of this challenge if you have to pick a winner. Now there are some considerations with the ELRS system. This radio had 0 interference through our dead zone, and even when we got to the top of the hill at about the 5.5 kilometer range and started cresting the hill on the other side, we still had signal. And this radio managed to go to 6.6 kilometers Very, very impressive. As noted in the video, our resolution started going down at about the 5 kilometer mark. So the servos were operating, but they were very stepped when they operated, so big chunks of movements. All right, and our last radio was the RadioMaster Boxer. Now, the Boxer radio also operates the same protocol, the ELRS system that is in the other RadioMaster setup. So with the Boxer, we were using the ER6 receiver, as mentioned, and we did our first run up at 100 milliwatts. The other RadioMaster was 250, and we did not get any glitches through the dead zone, and we managed to get 5.7 kilometers as our total distance. Now, interference happened at 5.5, loss of radio signal was 5.7, again, very impressive. Now, when we dropped it down to 25 milliwatts, which is the same frequency that we were operating on the FrSky radio, that changed things. So we did get interference at 1.5 kilometers, so the dead zone, and we did recover that, and we made it to 5.5 and lost signal at 5.7. So with the power of the radio dropped down, we still got our interference in the dead zone. When we were at 100 or above, we did not get the interference in the dead zone. So that's a bit of a summary for you guys of all the findings throughout these radios. Well guys, that's the radio test. I don't really care what the results are. You guys can take the results for what they are. That wasn't the intention to pick a winner or a favorite or anything like that. Obviously, RadioMaster did very well in this test. There's been some comments about the ELRS losing resolution at further distances, which is fine. If that's how you're going to use it, that's okay. But the point of this test was purely for information, for you guys, for everybody in the industry, and just have a fair comparison of all the radios under the same conditions. So thank you to Ward, thank you to Katie, Kellen, Russell, Joe, all of you guys that came out to help. I appreciate it. It's good to be able to do this. It definitely took a lot of hours put in to try and organize all of this. If you guys have any questions or comments, I'm sure there's going to be lots of people that have lots of comments. List those down below. Thanks guys for watching. Hopefully you got something out of this, and we'll see ya in the next video.